Mole is equal to 6.02 times 10 to the 23rd units. It's used to make groupings of molecules or atoms to make counting more efficient. In order to make counting more efficient, we cannot count the number of atoms or molecules in a sample, so we use what we call the molar mass. The molar mass is equal to 1 mole of the substance. The way we find the molar mass is we use the periodic table. Molar conversions is a way of converting grams to moles, some substance into moles. And the way we do that is we use dimensional analysis. There's 6 different types of conversions that you need to know. Grams to moles, moles to grams. In order to convert, you need what we call the molar mass. We find the molar mass in the periodic table. Particles to moles or moles to particles, we're going to use Avogadro's number to convert those units. And that is 6.02 times 10 to the 23rd. Last types of conversions are a little bit more advanced because it takes 2 steps. Grams to particles or particles to grams. You need both the molar mass and 6.02 times 10 to the 23rd in order to make those conversions. Here's how to set up each problem. Grams to moles. Notice how we have grams as a starting value, and then we want to get rid of grams, so we have the molar mass on the bottom, because the molar mass is equivalent to the number of grams equal to 1 mole of the sample. So when we do that, grams cancel out. Moles to grams, we're going to do the exact opposite, where we start off with moles. We're going to have the molar mass on top because we want to convert it to grams, and that is equivalent to 1 mole, and the moles cancel. Particles to moles, we're starting off with particles, so therefore we need to get rid of particles. We need to have particles on the bottom, so we're going to put Avogadro's number on the bottom and 1 mole on the top because we want to convert to 1 mole, or 2 number of moles. Moles to particles, we're going to start off with moles, and we want to end it with particles, so we're going to have Avogadro's number on top, equivalent to 1 mole. The mole cancels. The grams to particles is 2 steps. So we start off with grams. We need to get rid of grams. We have molar mass on the bottom. Those cancel, equivalent to 1 mole. And then we're going to have 6.02 times 10 to the 23rd. On the top, all equivalent to 1 mole, so the moles cancel on the bottom. Particles to grams is the exact opposite. We start off with particles. We get rid of particles, so Avogadro's number goes on the bottom. 1 mole goes on top. We want to end in grams, so the molar mass is going to go on top here, all equivalent to 1 mole, and the moles cancel. And we should get our answer. We talked a little bit about percent mass of a compound. And this is when you are taking the percent mass of an element within a compound. So the way you find that is you take the molar mass of that element times the number of moles of that element within the compound. The way you find the number of moles is you find the number of this little subscript next to it, and you multiply that by the molar mass. And then you're going to divide that by the entire molar mass of the compound, and that should give you percent. Okay? Again, this tells you the percent by mass of each element in the compound. Final thing we talked about was empirical formulas versus molecular formulas. And remember that the empirical formula is the simplified formula. How to solve for the empirical formula is this. If you're given percentages, you have to convert that to grams by assuming you're dealing with 100 grams sample. Once you find grams, you convert that to moles. Once you find all the moles of each element within that compound, you divide those numbers by the smallest value. And if you have to, if you don't get nice whole numbers, then you're going to have to multiply by some number to get a whole number. Those numbers now represent your subscripts for your empirical formula. Remember, the molecular formula is the actual formula, and it's equated to some integer Because remember, the EFO is simplified. It's some integer multiplied by the empirical formula. The way you solve is you find first that integer. The way you do that is you find the molecular formula, which is usually stated in the problem, and divide that by the molecular molar mass of the empirical formula. Okay? So you take the molar mass of the molecular formula divided by the molar mass of the empirical formula. You have to solve for that by just using the periodic table. This will be given. Okay, so you have to solve for the empirical formula, molar mass. You're going to be given the molar mass of the molecular formula. So you should get a nice whole number. When you get a nice whole number, you distribute that number by multiplying all the subscripts in the EFO by that number, and that is your